Hi, Ho students. Mr. Kaczynski with you. 4.9, practice your skills out of our book. Here we go. Without using our calculator, can we match each point of Olympic gold medal history to one of these three R values? So in graph one, we're looking at the men's 100-meter dash. So over time, the 100-meter dash Olympic gold medalists, their times have been coming down. That's the only graph where I see a negative relationship, this negative relationship here. So this right here tells me that that must be the correlation coefficient. It's also the only negative R value there. So I'm going to say that C is graph 1. All right. Now these two both have positive R values. It's a matter of which one's got the stronger relationship. I see this one as being a little bit more spread out. Maybe I should use a different color. A little bit more, I'm sorry, a little bit closer to a straight line. There is this fall off here at the end for the women's discus throw. It seems to be coming down over the last 20 years or so. But I think that's a stronger relationship. So that's probably this one right here, this 0.899. So 1 would be a perfect positive correlation, whereas 0 is no correlation. This is certainly not no correlation here on this last one because I can see a positive relationship. It's just that the data is more spread out than this, which is really close to a straight line, at least at first. So I think this men's decathlon points is graph 3. All right, so correlation coefficient is anywhere from -1, which is perfect negative correlation, to +1, which is a perfect positive correlation, and anything in between 0 would be no correlation. After a great deal of observation, Jason has discovered that the people sitting in the middle of the lunchroom leave earlier than those sitting on the side. He found an equation that relates the distance from the center of the room in feet to the time of departure in minutes. And here's his equation. Which of these is the best interpretation of the relationship? That is interesting. Okay, so people in the middle of the room, the lunchroom, leave earlier than those sitting on the sides. Okay, is it that being a fast eater causes you to sit in the middle of the room? I know fast eaters. I don't think that that would be their trait to go to the middle of the room. It doesn't make a lot of sense. Sitting in the middle of the room causes you to eat faster. I mean, I don't know why that would be the case. Why just sitting in a certain place makes you eat faster. There is some association between where you sit and the time it takes you to complete your meal. I think that's the one. Okay, there's some relationship there that he's noticed. What's actually causing it, we can't say for certain. We'd have to do a lot more studies, surveys, collect a lot more data. So there's some association. All right, the school administration looked at the number of semesters of foreign language studied and the SAT scores of 19 college-bound students. Here's those 19 students. We've got the semesters of foreign language that they took and their SAT scores. Find the Q1 and Q3 for both semesters and SAT scores. Let me give myself a little bit more room here. All right, so for semesters, well, let's put this data into the calculator here. We're going to edit a list. We're going to put these values in 0, 2, 3, 0, 2, 1, 4, 0, 0, 2. And then we got to put these in 4, 4, 2, 0. 1, 4, 0, 3. And 2. All right, let's get back to the main screen. We're going to go stat, calculate one variable stats for list 1. When I go down to the bottom, I can see my first quartile and my third quartile are 0 and 3. So let's type this in. For semesters of foreign language taken, Q1 is 0, and Q3 is 3. All right. What about SAT scores? This will take us just a little bit longer. Oops. Let's go stat. Over to edit here. Let's go over to list 2 and we'll put these SAT scores in. 1440, 1590. I probably should have had these pre-entered. You can fast forward, I guess, while I'm doing this. I'll leave that to you. You can do your own self-editing. 1860, or you could be doing it along with me, I guess. 1600, 2020. That's a good score, huh? 1390, 1500, 1750, 1920, 1770, 1630, 1500, 1660, 2230. That's a really good score. 1440, 1880, and 1710. All right, let's just take a quick look through there. I got the same number of data in each list. Looks like I got all my data entered in correctly. All right, let's go second. Quit, stat, calculate, 1 var stats, but this time I want list 2, so I got to hit second 2. Let's calculate this. Go down to the bottom, and there I can see my SAT scores. Q1 is 1500. Oops, I'm on equals. And Q3 is 1860. All right, use 2 ordered pairs from 3A to create a model for this relationship. Well, I didn't give ordered pairs. I just gave Q values, but we can make some ordered pairs. Let's go second stat plot, turn a plot on, and then zoom 9. So there's an upward relationship there. So I think I am going to use these 2 Q points here. I'm going to use Q1, or I'm sorry, I'm going to use 0 and 1500 as my first Q point. And I'm going to use 3 and 1860 as my second Q point. So to model the relationship, we're going to find our slope first. M equals 1860 minus 1500. That's our change in y, over 3 minus 0. That's our change in x. So that's obviously 360 divided by 3, or 120. So that means our slope is basically saying that for every additional semester of foreign language that you take, that you can count on your SAT score to go up 120 points. I don't know if I believe that. We'll get to that in a second though. So y equals 120 times, well, we got the y-intercept, so how about we just write it in slope-intercept form? 120x plus 1500. Let's graph that, see how it looks. 120x plus 1500. Graph it. Yeah, goes right through the middle of them. That's a pretty good model. Calculate the R value, so the strength of the correlation, which I think is pretty weak here. All right, so we're going to go stat, calculate, linear regression right here. Option number 4. And oops, I got to make sure that's L1. So I got L1 for my X list, L2 for my Y list. Calculate that. And it gives me a slope and a y-intercept, which is close to what I have, but it does not give me an R value. Why? Because I did not turn diagnostics on. I'm going to hit second 0 for catalog. I got to scroll all the way down to the D's, and I'm looking for diagnostics on. There you go. Enter, turn that on. Now let's run linear regression, and it's going to give me my R value. There it is, 0.894. So R equals 0.894. So there is a relationship there. Okay. What conclusion can we draw? There is a slight, well, how about just a positive correlation between semesters taken of foreign languages or language and SAT scores. So there's some kind of relationship there. Now, here's the question though. The administration wishes to make 4 semesters of foreign language a requirement for college-bound students in order to raise the average SAT scores for the school. Will this work? Well, so they're thinking if we require people to take more foreign language, their SAT scores will go up and that'll look better for the school. Well, I don't think that's going to work. Probably not. Correlation is not causation. Just because they are related somehow, it doesn't mean one is causing the other. In fact, I'd say perhaps more academically minded students that care about their GPA, tend to take more foreign language. So it's probably because the more academic students maybe are drawn to foreign languages. That might be the case more so than the foreign language is causing their SAT scores to go up, although it probably doesn't hurt. All right, we got this model. It's created for a set of data, which we don't have in front of us, but find the residual for each point. All right, so what we have to do here is we're going to plug 10 into this equation and see what happens when we get for an output. So we're going to do 47 minus 0.75 times 10 minus 12. I'm going to go to my calculator and figure out what this y value is. All right, so 47 minus 0.75 times negative 2, basically. 10 minus 12 is negative 2. And that gives me 48.5. So to figure out the residual, I am going to take this 50 and subtract the 48.5. And that's going to give me the residual, which is 1.5. In other words, the predicted value of 48.5 is 1 off from what actually happened, or the actual data point 50. Let's do it again. So here, we're just going to plug the 12 into the equation. 47 minus 0.75 times 12 minus 12, which is 0. So I don't really need a calculator for that, but if I put a 0 into this equation, I get 47 out. So all I want to do is 45 minus, where's my blue? There you are, minus 47. So what actually happened minus the prediction. And that'll give us the residual, which in this case is negative 2. One more time, here we go. Let's put 15 into the equation. Kind of repetitive, right? 0.75 times 15 minus 12. which is just 3. So let's go back here to the equation. Second enter brings up my old equation, change the 0 to a 3, 44.75. All right, so I'm just going to take what actually happened here, this 44, and subtract the 44.75. And that'll give me my residual, which is a measure of how far off the prediction was, which is just negative 0.75. That's all there is to a residual. Go back, read a couple pages in your book like you're supposed to before you start the practice your skills, and you'll see what a residual is. So there you go. I hope that's very helpful to you. Remember, I'm not doing these to do the work for you. I'm doing these so that you can check your work. Although obviously there's going to be times where you need to check this just to get you in the right direction, going in the right direction.